All right, let's just give it a couple of minutes for people to show up and then we'll get started. All right, let's get the party on the road. Our first speaker is Yifeng, and he will be talking to us about his journey building Affine Official. It's a wonderful app that is trying to be your all-knowing knowledge base, open source, local first. You really can't ask for more. So I'm going to hand it over to Yifeng to give us a breakdown of their journey, their CRDT experience, and this is going to dovetail really well with Matt, our resident doc, who will be breaking down even more advanced concepts in the CRDT space. All in all, a wonderful lineup prepared for you guys today. I hope you're all excited as I am. Off to you, Yifeng. Yep, you're coming in great and video's working.
We think it's very great for building collaborative apps, no matter if it's local first or cloud-based. So regarding the functionality of Affine, I can have a very brief showcase. And you can see the outline of my talk is written in Affine. And this client looks like a general launch base. You could create many different workspaces. And in each workspace, you could create many different pages. And as you can see, every single page looks like a regular document. But as long as you click on this button, you could turn it into a whiteboard immediately. And this could allow for quick brainstorming and could be very convenient to allow you to use a straightforward way to navigate through contents. And this is exactly what we set in our one-liner called write, draw, and advance. So in Affine, you could use a notion like block-based editing features. You have the splash menu, you have the some blocks to insert, and you can have the grab handle to rearrange the blocks, and it allows you to immersively to write content, and you can also switch to the page, the whiteboard, that allows you to draw some graphics content. So, hello. Well, seems does work. And also you could set some blocks and turn them into a database, and which is great for task management and planning. And already
Yifeng, do you want to maximize the window?
Okay, sure. And as things work a bit better.
Yep. So, and if you could zoom in or something.
Things go to work. Okay. Good.
Don't worry about the
So
Q&A.
up
We'll handle
here,
that at the end.
oh, that's great. That's great.
Maximize the
So
window?
already here, this what we have demonstrated before has involved many different editors during the user journey, but we have managed to make these editors to share a unified data model
Don't worry
and
about the
UI
Q&A.
infra
We'll
so
handle that
that
at the end.
the user experience could be as smooth as possible, rather than use many different tech stack to compose the product that has pretty much inconsistency. So what are these features relate with local first? So firstly, all these features and the content you created are fully offline usable, rather than like Notion that you have to store your data into the cloud server. And you can see in the workspace setting page, you could customize the storage path of the underlying database of the workspace. And more importantly, we believe that an ideal local first app should allow you to collaborate with other people at any moment, which makes one major difference between Fi and other um, knowledge based application, which is that we are not actually save this page into the plain text files, but rather model the page as a CRD branch and the directory in the option challenging the main format is and it of CRT
Sorry to interrupt again, Yufeng. Your audio is cutting up again. Um, Maybe if you stop sharing for a second and then try sharing just the window, maybe that might alleviate some of the problems that we're facing. Classic geo issue. Your audio is cutting up again.
the network pattern for now.
Your audio's coming in good now. Try just sharing the window, and maybe that might save us some bandwidth issues.
You are muted.
Oh. All right, your audio's coming in great now. Try sharing just the window, and then hopefully that should alleviate some of the bandwidth.
Yeah, I'll try to do it. So I will switch between the browser and um,
It's a classic. Last time we had a couple of issues as well, and we're still working through it. And Socket Supply folks have actually been talking about some sort of a way to do peer-to-peer video conferencing and peer-to-peer community building. Hey, so that might be the first local first
so
implementation. All right,
does
take it
this
away.
work for now? I'm really not sure.
No, things are
Yeah.
clear right now. Go for it.
Okay, sure. Well, so basically, what we are building is that we store the document of the workspace as the CRD block trees and encode it into the database files. So, and the huge benefit is that we only need to merge the update patch from different clients with any order. We could have the identical merge results and leads to a conflict-free shared editing. And this kind of collaboration ready capability means a lot to our product because traditionally many file-based note-taking apps are local only and they could support single user mode syncing and backup. But when it comes to multi-user collaboration, this pattern could easily lead to conflicts, and which is that some web-based products is more suitable for team usage. But for Fi, it could not only ensure your control over the data, but also supports the multiple user collaboration, which is just like in this screenshot, and which means that we want to take the advantage of both the local app and web apps. And but this power of CRDT is not only about changing how a file stores data, when we are building a file, we gradually realize that CRDT has a more important usage, which is that it could serve as a general purpose state management tool. So based on this pattern, we implemented the um, data one-way data flow in the editor in a file, which we showed here, which is that basically in traditional editors you will have a native editor model, and if you want it to be collaborative, you will have find the CRT library and have build your own binding between these two models, and um, things could work, but when it comes to um, when it comes to non-collaborative apps, you always need to do these things like that. So why not just use the CRT model as the native model, and that is what we do in the editor in the file, and which leads to this kind of data flow, which we think is pretty simple and straightforward. And the things here is that since we have the CRT model as the native model, and no matter sometimes no matter what kind of state changes come from, because we can have multiple uh, data sources. For example, I can manually update, for example, have enter to insert a new block here, or to have when we have a web socket, there could be some remote updates coming, and perhaps sometimes we perform undo redo operations, and all these operations will generate a state patch like the git diff, and it will be recognized as the Y event, and we utilize it to update the block tree and then update the corresponding UI components. The good thing is that as long as you wire things up for once, for all the application layer codes, we could completely ignore whether the updates come from and just subscribe it and it's adequate. It makes the editor collaboration ready and intrinsically, and from the day one and we build the editor, it already supports multi-user collaboration. And another great advantage that CRDT could gain is about rich text editing. So traditionally, a full article in a rich text editor will be put inside a so-called content editor. For example, I take a look at the SEO editor by Facebook, the content editor, and post a whole model tree. And this utilizes the browser native capability, but will be very risky because you have your control, and when you are performing some dangerous operation, our browser will take it on. In Broad Street, you can think about that when there are 100 blocks exist um, in the page, we will have 100 text box and 100 different text editor instances, which means 100 different content editor, and each content editor attached to one CRDT rich text instance. So in this way, for non-text blocks like the images and tables and more complex UIs, they no longer need to put inside a content editor anymore. This could significantly improve the safety of the editor and make the blocks could be built by more simpler UI frameworks. The prerequisite of doing this is to have a centralized block store to orchestrate the state of the blocks. For example, if I select through multiple blocks and delete them, I need to handle them across different instances of the editors, and which is perfectly handled by CRDT because I could have a nested complex JSON alternative structure. So based on this simplified architecture, every single text block in this editor only utilize a very few functionality to traditional rich text editors, and which makes us only cost a few weeks rather than a few months to implement our own rich text editor, and we call it Virgo. And if you want to use it, you could have it in our own GitHub repositories ready. And one last benefit that this pattern could bring is that because all the CRT updates could be encoded incrementally, so this could allows us to always have the incremental synchronous model updates by calling the APIs, things like add block, update block, things like that. And in this case, the assembly binaries stored in memory will immediately be updated, but the underlying I/O operations could be handled by providers, no matter the data is stored in locally or cloud-based, and we could just handle them in this way. And so perhaps I will try to switch to another window. Well,
Is Blocksuit the name of the company?
so this is the editor we built in Afine. So
Gotcha.
here we have a simple explanation about what is upcoming. We will have the Afine clouds and in next major release. So for example, for now, the whole client works locally, but based on the architecture we mentioned, and it's just a plug and play extension of our cloud service. And we are also working on the extensions that allows you to install more block types and third-party integrations and more support for more data formats. And when Afine become more mature and could be more commercialized, we are also planning to make all the infra that we have built in Afine, including rich text editors, the UI components, and things like that, and our data store, open source. And it's already open source for now, but not very much advocated in the community. This mainly includes two parts. The first part is the block switch, that is the editor project we just mentioned about all the rich text orchestration and one-way data flow stuff. That is the editor project behind Afine. And another project is called Octobase. It includes the different network providers and local database that serves as the backend. So basically, and we are currently working on these projects to suit the needs in Afine, and we're really looking forward to bring more this kind technical product to the community. And that's pretty much everything. And thanks for listening.
Awesome talk, Yifeng. And love all the work you've done to build out Affine. I'm especially excited about that. And Skiff is another one that we're trying to get to come and present next week. They've built sort of a pages, email, calendar setup. Might even have this CTO on call. So we're loving this energy to put users at the center of their data and move away from the siloed, really tall walled gardens world that we've currently been forced into. It gives me great pleasure to introduce our next speaker, Steven. If you can't tell that I'm excited, I'm repping their swag and just the beauty in which they built a UX designed to solve some of the underpinning things that Yifeng vertically incubated with their Affine product is just amazing. Going direct to platform is challenging, so mad respect for you, Steven, and I'm looking forward to hearing your talk. Off to you.
All right, thanks. Let me share my screen. All right, can you see that?
Yes, sir.
Can't see my face, so I'll just assume you can see my screen.
I see the way.
But hi everybody, I'm Steven. So I currently live in Paris, but I've been kind of all over the place. Lived 7.5 years in Sydney, Australia. Moved to the US for a little bit to work at Envision and Messenger, and I'm now back in Paris. So you see that? I now run a company called LiveBlocks, which essentially is a company that helps developers like you guys build multiplayer and real-time collaborative applications. And so my talk today is about, it's not quite about local first, but I promise there's a link there. It's about the fact that multiplayer isn't enough. And so I want to give you a quick kind of overview. I know you're all super familiar with this topic, but I just wanted to give a bit of context on before I get into the demo. So if we look back, this is kind of like the first sort of player into building multiplayer collaborative apps, and that was Google back in 2006, I think, if I'm not mistaken. They introduced Google Docs, and they had technical expertise and millions of dollars to invest in this problem, and they were able to pull this off and take a ton of market shares from Microsoft Office. And so since then, obviously, the UI and the UX of this has improved quite a bit. But all that to say that 15 plus, almost 20 years ago at this point, they were pretty much one of the only ones that were able to pull this off. And it required, as I said, a lot of engineers and expertise to do this. And then I guess most recently, and I know they had, I think, a conference last week, Figma Config. And I'm super familiar with this because I come from a design background, and I was working on a competing product with Figma at InVision, and they personally blew me away, because when they came out and created this design tool in the browser, I was the first to say, like, no way, I'm not gonna use this. I want to use my own kind of design tool, macOS app like Sketch or Photoshop, and I was convinced. But they proved everybody that actually having an application that works in the browser that's multiplayer collaborative by default, you get a link, paste it, you get everybody to collaborate on the same page, was actually super, super helpful, right? To collaborate with engineers, product managers, stakeholders, you name it, or even customers, right? Clients, or if you wanted to test your app, you could very easily do that by just sharing a link. So what they proved there is that you could actually do this, but you still needed technical expertise and a lot of money to actually pull this off, right? They had Evan Wallace on that team that did an amazing job, kind of building this in the first place with like some engineers, but that was really hard to do at the time. And then there's probably more companies, but I'm just trying to simplify this. There's companies like Canva, Mural, Notion, Mirror, Linear, Pitch, that were able to pull this off, I guess, most recently. And those companies again had funding and quite a bit of technical expertise, but they started, I guess, Figma kind of led the way after Google to show that, okay, let's actually start making our products a lot more collaborative by default. And so I have a question for you guys, and I'm not sure you'll be able to answer, but what do you think those products have in common? Right? I guess the most common answer to this is like, all right, I think somebody was gonna answer.
I was just gonna say real-time collaboration.
There you go. All right. That's right. Obviously, real-time collaboration, or you can call it like a multiplayer editor, kind of up to you. But the idea is that you're able to have multiple people in that document working together at the same time. But as the title of my talk said, this is actually just one small part. I mean, it's pretty important. It's kind of the foundation of that collaborative experience, but you need a lot more. And so let's have a look at some of the patterns that all those companies and all those products have. So number one, that's pretty obvious. You have sharing and permissions. If you look at Google, you can invite somebody by typing their email, and they will get a notification by email, and they will be able to join that document. Same with Figma, same with Notion, and same with Pitch, and same with all the other tools that I shared earlier. And they also have this concept of permissions, right? You can be an owner of a document, you can be view only, or you can have write access. But all that stuff is really important when you build those products, right? And it's pretty hard to get right. Oops, I went back. And then they also have, what do they have in common? They all have comments, right? You can leave a comment. You can leave a specific annotation in Figma where you like click on the Canva or on the layer, and that comment will be attached to a layer. In Google, like you can select a text and leave a comment on that text selection. Same with Notion and Pitch, kind of the same vibe as well, where you can leave comments directly on slides. And one thing that I didn't mention as well is that you can also mention people here, right? So when you mention somebody, that person also gotta get a notification in Slack, Discord, if there's Discord, kind of up to you as an app builder. But those people will get notifications and they will be invited to that document. And then lastly, there's another thing that pretty much every SaaS product has. They all have a way to browse documents. And that seems trivial, but that's pretty hard to do when you start thinking about like pagination or like loading a ton of like thousands of documents at the same time, or when somebody is in a live document and they start making changes, all of a sudden you need to update that view with like a new thumbnail, a new title, and that sort of stuff. So all that to say that making all that stuff work nicely together, multiplayer editor, document browsing, comments, and also sharing and permission, that's pretty difficult. And so great collaborative products are actually much more than just multiplayer editors. Building and maintaining and scaling collaborative products takes time and expertise. All those companies, all those products had amazing engineers, amazing designers, and budget to actually pull this off. And I've witnessed that myself, right? At InVision, I was part of the team working on like moving InVision Studio from a desktop-based application to a browser-based application, and it took us about a year and a half to do that. And the result at the end wasn't quite as good as what Fima was doing. So it takes time and it takes expertise. It's really hard to do. And so, it's hard to do because obviously all those things, how do you maintain and scale WebSocket servers? How do you handle like, stuff like data migrations, permissions, also observability? Like when you start building real-time apps and you have like thousands of people that can manipulate the same real-time state, how do you log that? How do you make sure there's no bug in your app? How do you handle those like weird states? There's a lot of stuff to think about. Even WebSocket connection logic, right? When somebody close their laptop overnight, how do you actually reconnect? There's a lot of stuff to get right there as well. And obviously that's more linked to this meetup, but also offline support, right? Making sure that your app either work while you're offline, or maybe it can be local first. So there's a lot of stuff to think about there. And so that's what we're trying to do at LiveBlocks. And so our goal is to be the real-time collaboration infrastructure to help developers and companies build those kind of collaborative experiences, so that you can focus on your own product and you don't have to do all that stuff yourself. And so if you look at LiveBlocks, and I'll get into the demo in a little bit, it's basically structured in 3 different areas. So we got our products. So we got presence, which enables you to show like a live avatar stack or like live cursors and that sort of stuff. We have a concept of broadcast, so that if you want to broadcast events to all the other people that are currently in the same room. So for example, right now in this Discord channel, I could be broadcasting an event to all the people kind of currently listening in this room. And then we have storage, which is a solution to store the document's data and enable multiple people to edit the same data of that document simultaneously. And then we have comments, which is it's in beta right now, and that enables people to kind of build a commenting panel, being able to like mention people and have those people being notified. And to integrate with those products, we have integrations. So right now we have a JavaScript client, Redux, and just a client. We've got more coming, and that's basically the way you integrate with LiveBlocks depending on your framework and the app you're building. And the real power of LiveBlocks comes from the actual platform that we then offer, right? Where you have, essentially we provide the WebSocket infrastructure so you don't have to worry about that stuff. We also provide stuff like a ton of like REST APIs, so that if you want to extend the product and add specific features to your app, we provide all that stuff, analytics. There's also like a schema validation that we're currently working on that enables you to like validate the data of a document on the server, which will eventually help also like with data migration, which when you build a real production application that's that's pretty important to do, and stuff like dev tools and webhooks. But let's get into the fun stuff, actual demo. So I wasn't sure what to demo for this, and I was like, there's a lot that we can do with live blocks. So I actually thought the easiest path would be to actually use our starter kit. So we have this starter kit for Next.js, which basically includes pretty much of all the products that we offer in like one nice app. So I'll show that to you now. So I'll just close this and show you how it works. And please let me know if I'm going over time. Where's the terminal? Alright. So I can just paste this, and this will ask me a couple of questions. I'm gonna zoom in a bit. Is this big enough? Just want to make sure you guys can see. I'm gonna name this, let's say, local first meetup. And it's asking me, okay, what sort of authentication system do I want in my app? So I'm gonna use, you could use Azure or GitHub, but for now I'm just gonna use a demo view. I want to deploy to Vercel, and I want to install with npm. And now what it's gonna do is actually gonna open Vercel for me automatically from the terminal, and I can start creating my Git repository here. So I'm gonna create my repo. And I hope Vercel will be fast enough here. So I'll now add the integration, the LiveBlocks integration to this. There you go. So I am logged in, that's cool. I'm going to create a new project, and I'm gonna call it local first meetup. And I'm sorry I have to hide this window because there's gonna be an API key showing up otherwise, so I'll just sort of try to click and move it really quickly out of the way. And hopefully you didn't catch that.
Nope.
So so now I can import my API key, and it's gonna close that window and go back to Vercel, and it's starting to deploy. So alright, so this should take a couple of seconds, maybe 20 seconds or something. So
this looks like magic. Like
yeah, I mean the team did an incredible job on that one. It just makes it super easy to get started. Obviously, if you have an existing app, like maybe while it's building, I can show you some stuff. If you have an existing app, by the way, I don't know if you've seen, but we just launched a brand new documentation today, like literally an hour and a half ago.
Thanks.
So yeah, I'm pretty excited about that one. There's a ton of like get started, like quick step. But if you use something like React, you know, you can obviously get started like if you have an existing app, like very quickly installing the packages. And it's like 4 or 5 steps, and you're ready to go. But we can dive into this a bit later. Oh, okay, cool. So it's been deployed now. Yay! Party! So sweet. So now it has been deployed. And so now I should have, if I open the terminal again, let me see, where's the terminal? There you go. So now here's my, I'll just go cd local first, boom, open, to make it easy for me. And I'll open that into VS Code. Yes, trust the authors. And then what I can do here is run, this already installed everything for me, so now all I need to do is do npm run dev, and it's ready to use. So I'll just do localhost ding, and now I logged in earlier, so I'll just sign out for a bit. Oh, I have another one. I had another demo running, that's probably why. So I'll just quit that one and start again, run it again. Okay, now I'm on 3000. Sweet. So this gives you essentially a Next.js app with like a marketing site homepage, a way for you to sign into your app. It basically provides you all the surroundings and all the foundation you need to build a SaaS product that's collaborative. And so here, this is just a fake sign-in because I picked that in the terminal. But you could obviously integrate that with whatever you want, GitHub, SSO, or Auth0, or Clerk, or whatever you need. And here I'm gonna sign as Charlie Lane, and now this is all using Lightblocks. So now I can create a new draft, and I'm gonna create a whiteboard. It's a pretty basic example. I'll show you the code afterwards. And now, the good thing about this is actually live, right? So if I open this and go like this should be the same exact app. And now if I copy this URL, paste it here, this should work. And you all are welcome to join me in this whiteboard if you want to play.
Can you drop the link in the chat? And it says not allowed access. I don't know.
Yeah. So this is on purpose. Not allowed is because you don't have access yet.
Okay.
To give access, I'll just do this and enable public share link, and this is all powered by Lightblocks. And now, if I refresh, boom, this is live. And I'll share the link. So the link should be. Oh, looks like somebody. Oh, it's just me, I guess. So I'll just copy this, and I'll paste it in the chat. And we should all be in the same whiteboard. There you go. I see a lot of people joining, and you guys are in read-only now, so you should see my cursor. I can type hello. Well, let's have a bit of fun. I'll enable edits on this. Allow anyone to edit. And now you should all have edit access. There you go. Start seeing you guys. It's really cool to see. Nice. And now we can start typing. We can start working together. And there's a ton of cool features. Like, if I start typing here, I can undo my own changes. I can redo. I can do a bunch of stuff. And so, just to give you an idea how the code looks like for this, I'll just open. I think I forgot where I installed it. Okay, here. The way this is set up, and this is gonna be the end. I don't want to take too much time of the meetup, but essentially, you got this config file when you use Lightblocks that you can set up, and we have a command to set that up very quickly. And you can set up your own data for your document, your own presence, your own storage. So for example, presence here, it's literally just like a cursor that has XY coordinates. And then we have a map. If you look here, this is a map of nodes, and a node is like a live object with XY coordinate, a text in it, and an ID. And then we use storage, and this storage is all kind of a conflict-free data structure solution that you can have multiple people manipulating the same state. And then you get all those nice little hooks to do a bunch of stuff. So if I go into the whiteboard component, what's interesting is trying to think which one is good to show you.
You've lost most of the
maybe
people.
Mr.
Everybody's flying around in the little canvas.
Yeah.
But
All right,
just
back to the class.
back to class, everybody. Then let's see how this is done.
Class. I can't wait to see what you guys wrote on this. But yeah, I mean, there's this config file I was saying with ton of hooks and stuff to make it very easy for you to integrate Lightblocks within your React application. One thing that I kind of highlight everything here, but one thing that I find super valuable is we have API around history and undo redo. So if I look for history here, literally to do a undo button that you have in the toolbar at the bottom, all you have to do is history undo, and that will handle a multiplayer undo for you. If you want to do redo, it's kind of the same API, and that makes it very, very easy to build multiplayer applications, collaborative applications, not only for multiplayer but also all the collaborative aspect of it. The one last thing I want to show is that wow, that was a lot. So if I go back to the editor here, on the workspace, you can see that this view is actually live. Is actually live based on like how many people are here in the document. So we also provide the APIs to very quickly build like a pagination, like workspace system where you can like have permissions and browsing. And so here, if I create a new draft, and I'll open this here instead. And now you can see that this is live, right? As I'm here, if I change the title, say test, it will automatically update on the left. And for that we use SWR. You can see test kind of edit here in real time. If I go back to this one, change it to like yo local first, I don't know, and I can type, and it's live. One thing that I didn't show here, I just want to quickly highlight this. I promise I'll stop afterwards. We've got this. I talked about observability a bit earlier. We do have a LiveBlocks dev tools, and to me that is super important and super helpful when you start building super interactive applications like this. So here we have this dev tools that shows me literally all the data in real time. So here I can see that XY is moving of this object. I'm trying to find, there's a ton of objects here, so I need to find the one that's highlighted. You guys added so many to-dos here. Is this local first? Trying to find it. Hello, nice content, please. Hi. But yeah, here you can see also like cursor as I'm moving around. I can see my own presence kind of updating in the bottom right corner. I don't know if you see here. I'll just try to make it a bit bigger. But you can see like my own presence, like the XY is moving here as I move around. Nice. So we got like a ton of tooling like this that makes it super easy to kind of build those type of experiences.
That's awesome.
And I'll pause here. I'll stop. Happy to dive into the code a little bit later if that's helpful. And yeah, I hope you guys build stuff with LiveBlocks. Thanks.
Amazing presentation, Steven. You did not let me down. And it's almost in par with our previous speaker from our previous meetup. We had a Excalibur come and give us a presentation. As you can imagine, everybody took a hard left. Same with Replicash. There was one point that was made, like, is this cloud-based and like, is it relevant to local first? I want to make a community note here that we really want to focus on progress. Local first as a name and as a theory and a way of qualifying products is all fine and good. Lo-fi is kind of what we're going for with this community, for trying to create a world where it's not locked away behind silos and be as committed to the ideals in the ink and switch paper. So let's be welcoming to different ideas. Cloud centralized sync resolution is not a bad idea. If the rest of your app is completely local first, then you need to offload some of that work. So that's a little bit of context there, but Steven, be ready to answer that question in the Q&A section. Now, I'm really excited to get Matt on the floor right now. He's been one of the OG members of the Lo-Fi group, and if you haven't checked out his website and blogs, it's the only comprehensible like interpretation of CRDTs. And I'm saying that after the 8th reading group of CRDT papers, and I always have to go back to his page. He recently published Fugue, and that was the topic of the last I think two reading groups ago. But enough introduction. Matt, take it away and teach us some stuff.
Okay, thanks, John. Okay, wait a second. Is the slides coming through?
Yep.
Okay. Yeah, so I'm Matthew. We talked about Collabs, which is a library that me and some other CMU folks have been working on for the past few years. It's going to be hard to follow up the LiveBlocks demo, but I'll do my best to keep it engaging. So in short, Collabs is a TypeScript library for managing collaborative state. You see a link to our docs website here. It's designed to let you make collaborative apps like, say, shared wakeboards. And particularly, it's the state management layer, so it tells you what the state should be, even when multiple people are editing it at the same time.
From a programmer perspective, we try to make it look as much as possible like local data structures, meaning that you get these data structures like the collaborative value map. You can set key value pairs in the map, like to make a pixel green, and then other users can just ask the map for its entries to see what the current state is. So the whole library is built around these collaborative data structures, sort of modeled on YGS's shared types, if you've seen those. It supports live collaboration as well as merging save states, like if you have two different users make a bunch of changes independent of each other, you can merge their states. Under the hood, these are using op-based and state-based CRDTs. It is network and storage agnostic, meaning you have to provide those or sort of plug and play. And it really should be local first ready. So it's okay with offline mode, peer-to-peer synchronization, you can store stuff in local files, all that good stuff. So now Collapse is similar in spirit as well in some of its techniques to YGS and AutoMerge. All three of these libraries use in-memory CRDTs. They're all network and storage agnostic. More broadly, we have collaborative state management libraries like ShareDB, Fluid Framework, Vulkan, et cetera, et cetera. So of course, the first question you should be asking is what's special about Collabs? In other words, why would you use Collabs instead of any of the many existing libraries? So I'll explain that as the talk goes on, but first I want to start off with a demo. So here is a demo of a collaborative recipe editor made using Collabs. For sanity, I just have two windows on the same desktop being recorded, but of course this would also work if you were running it on two different computers. You see we're synchronizing the title, got some ingredients, Quill rich text editor showing the instructions. Under the hood, this is a pretty standard desktop web app. We've got Electron, React, Quill for the text editor, and of course Collabs is the source of truth for all the state that you're seeing. Oh, yeah, and there's a link to the GitHub page. These slides will be on my website, mattwidener.com, so you can come through later and click on these links. So underneath, to actually synchronize the changes between different windows or between different devices, we're using Dropbox as a sort of budget local first sync engine. I say budget because it means we don't have to run our own servers. Dropbox is doing that for us. In particular, when you make a change, your window will save it as a file on your device. If you put this file inside your Dropbox folder, Dropbox will send it over to your collaborators. They'll load it up and see the changes once they get that file. So this means that Dropbox is handling for us the cross-device sync. It also manages things like permissions when you share with different editors. And under the hood, it's not actually saving things just to a file. Normally, it's saving to an array of files in such a way that using Collabs, we ensure that there are never any sync conflicts. You never get any sync conflict warnings. In particular, if two users or multiple users make changes concurrently, independent of each other, then once they see these changes, they'll merge all of their states together, merge all the updates, and see what everyone's been doing. So one interesting feature of using Dropbox for collaboration is sort of designed for slow collaboration. Not really the live mode like Google Docs where you type a character, you expect everyone to see it instantly. Instead, you sort of expect that sometimes you make changes, it'll take a while to reach your collaborators. Maybe you're offline, maybe you just pause syncing. In this case, it means that merge semantics really matter. If two users make independent updates and do a lot of work independently, and when you come back and merge those states, you want to make sure that you're not losing a bunch of data, and you try to preserve their intention as well as possible. Otherwise, they'll have some mess to untangle later. So in particular, there's tricky situations that can happen even with a similar recipe editor. You say, what happens if two users concurrently move an ingredient while someone else is editing it? Or what if I delete an ingredient while someone else is still working on it? Or what if I scale the entire recipe while other people are doing a bunch of manipulations? So these are all situations where merging those changes afterwards is kind of tricky. And I believe if you use most existing state management libraries, they'll probably do something you didn't expect. Like maybe you'll move an ingredient, it'll just lose everyone else's edits to that ingredient they haven't concurrently. But now let's see what actually happens in our Collabs-based recipe editor. So first demo, we got an offline user on the right. I've disconnected them. They're going to move this pepper ingredient to the top of the list. They really like pepper. They think it's important. Meanwhile, concurrently, this user on the left, they just make a little edit. They say it has to be black pepper specifically. Let's see what happens when we merge these changes. So now you can see we've got our edited ingredient, black pepper, at the top of the list where we expected it to be. I'd argue this is sort of the result that the user expected. Okay, second example. Got a disconnected user on the right again. They're offline, and they're going to delete the oil. It's unhealthy, so we're getting rid of it. Meanwhile, the user on the left, actually, they like oil, so they're going to increase the amount a little bit. Got 20 milliliters now.
Now let's see what happens when we merge these states. So you can see the oil has reappeared with our edited amount, 20 milliliters. Basically, we didn't want to forget about the edits that the left user made, so we brought the ingredient back. It's sort of a toss-up whether this is the best behavior, but it's nice that you're not losing any data, and it's also easier to patch up afterwards if you just delete the ingredient again, if you don't want. For a third behavior, the user on the right, they've gone to the grocery store, and they get there, and they see that actually heads of broccoli come in packs of 2, not 1. So they want to double the whole recipe. We have this magic double button that does that, doubles every amount. But meanwhile, the left user back at home in the kitchen, they're making a bunch of tweaks. They say, I'm going to make it 10 milliliters of pepper, and I'm going to add a hefty serving of cheese, 1 kilogram per head of broccoli. So now what happens when we merge these changes? We have to be really careful, because if we just apply like a last writer wins rule, say, then we'll be choosing between 6 or 10 milliliters of pepper, neither of which really makes sense. We also have to be careful that we double the amount of cheese so that it's still in a 1-to-1 ratio with the broccoli. So let's see what actually happens. You can see we've basically merged all of the left user's edits and scaled them. So we've got 20 milliliters of pepper, got 2 heads of broccoli to 2 kilograms of cheese, so everything's stayed in the correct proportion. Which again is, I argue, what the user wants. Okay, so that's it for the demos. Now I can return the question of why collabs. And the answer is that collabs is designed to let you implement and reuse custom, nuanced behavior like you just saw. So in particular, we saw the example of moving versus editing ingredient. We want to make sure that you move and also preserve edits. When you delete versus editing ingredient, we've chosen that the edit should undo the delete. You can also choose the opposite way if you'd like. And with scaling the recipe, we've made sure that it scales each amount, including amounts added concurrently. It's sort of a tricky thing to do. All 3 of these semantics come from recent or recent-ish CRDT papers. They all have somewhat non-trivial algorithms, but with collabs, we're able to implement them without too much difficulty and then build them into the app. In particular, the third behavior isn't actually built into collabs in any sense. It's not part of the core library, but we were able to add it as a custom behavior in our app, basically because collabs allows you to add your own custom collaborative state management. So here's a really simple example. We talked, so at the last local first meetup, Aaron Goodman talked about how if you want to count in YGS, like people boarding a train, conductors at different doors are counting, then actually the way you do it is you append to a list and read its length. It's a little awkward, but sort of the way YGS is designed is all CRDTs are a list under the hood, so it's sort of your only hammer. But you'd really rather just send +1 messages around on the network and count them locally. In collabs, that's exactly what you do. So you can define a new class like collaborative myCounter, say I want it to be a primitive CRDT, and it just does a simple algorithm. It's got a value, an increment method that sends a +1 message. When you receive this message, you increment your local value, and then you can look at it later. This is nice and simple. This isn't quite the whole code. I'm omitting the part where we load and save the state. And actually, if you want to do state-based merging, you need like a state-based counter CRDT, which is more complicated, though for mathematical reasons, not really API's fault. But if you want to see the whole code, there's a link here. There's still only, I think, like 50 to 100 lines. Maybe a more complicated example, if you think about a recipe, no library is going to have a built-in recipe CRDT, that's just too specific. But we'd still like to do a bit of data modeling, sort of shape the data to mirror our DOM tree, just for organizational purposes, even if we're not doing anything clever. So that's exactly what we do. Collabs lets you define a new class collaborative ingredient, which you say is a collaborative object, meaning you get to make use of object-oriented programming and encapsulation without actually doing anything fancy CRDT-wise. Instead, it's just like a wrapper for a text for the amount, a text for the name, an amount for the amount, some units for in a variable. And then you can take this ingredient, you put it in a list, or built-in list class. You get a list of ingredients for the left-hand side, some rich text instructions for the right-hand side. You can encapsulate this, hide the ingredients list behind an add ingredient method, etc. And I'll just point out some things here. So we've got this strong typing, where we say our units variable. It's not just any variable, it actually has type unit. And we also put our custom ingredient CRDT into Collab's built-in list. So all these things, they sound sort of trivial if you're thinking in terms of normal local data structures. It actually took some effort to get them working in Collabs. And as far as I can tell, there's sort of unique features that Collabs lets you model your data in this way, including with strong typing, custom things that go in built-in lists, etc. Of course, I'm omitting some more boilerplate here that goes into the constructor. You can look at the full code if you want to see what I'm hiding from you. So now maybe a more complicated example. I remember I talked about how when one user moves the ingredient, like they move the pepper to the top of the list, but someone else was editing the pepper to say black pepper, and we want to somehow preserve both of these changes. So there's a paper about this. Martin Kleppman wrote this paper, Moving Elements in List CRDTs, which says basically if you want to implement this behavior, you shouldn't use a traditional list CRDT. Instead, you should use a set of pairs, value, comma, position. And when you want to move a thing, you just set its position to a new place in the list. So let's see how we do this in collabs. So first off, we make our pair class. This is another trivial object class that just wraps the value in the position. And then we make a list as a set of these pairs. And also we have this position source, which does some technical stuff, basically telling you how to sort the positions in the list. So that's it for CRDT state. We've already got an eventually consistent object. Now we need to define operations on top of it that do what we expect. And sort of in pseudocode, when you want to move an item, you just get its entry, you make a position, the place you want to go using the position source, and then you just say entry.position.value equals pause. Now everyone's states will update so that they still have the same set of pairs, but the pair in question, its position has been moved to the right place. So of course, this is omitting a lot. In particular, the hard part of this class is we want to maintain a view of the actual list for efficiency reasons. So it's just like a local view of what are the actual list elements in order, how many of them are there, etc. So most of the code deals with this view maintenance, like, when the CRDT state changes, update the local view to reflect the new list state. It's kind of tricky. But the whole thing is still less than 300 lines of code. I think it's pretty readable. You can check it out, this link here. This is built into Collab's list CRDT. So you don't have to, you get this move method automatically. Okay, so now this sort of highlights an idea which I'd like to propose is that we can use Collabs not just as a library for making apps, but really as a CRDT laboratory, a collaborative data structure laboratory. So we start with the core library that you have to use, and then our built-in CRDTs like paratext for rich text, fugue for lists, the optimized OR set, which I know is the subject of last week's reading group, etc. But then beyond that, it's possible for other developers, like academic researchers, to add their own extensions to Collabs. For instance, maybe a researcher will come up with a spreadsheet CRDT or a faster text editing algorithm. They can then implement these, basically each data structure as one class, publish it as a third-party library on NPM, and sort of keep Collabs up to date with the research, even if we don't get around to modifying the library. And then even further, if you're making an application and you don't have the right collaborative data structures for your needs, you can just implement it on top of the library, again, without forking the original source code. And you can use these to do things like, scaling the recipe. That wasn't a built-in behavior. That's a special behavior we implemented just for this demo. Maybe if you want to do optimized wire format, really like nitty-gritty optimize the bits you're sending over the network, and who knows what beyond that. Okay, just to repeat about performance, I know this is sort of the CRDT bogeyman. It's like, what if they use too much memory or too much time? So here's Collabs built-in text editing CRDT versus YJS, just sort of the state of the art in this space. And we're just running it over a text editing trace that Martin Kleppman made. That's like 260,000 operations, 100 some kilobyte document. You can see for the entire trace, we're able to send, tens of thousands of operations per second, and worse than YGS, but still way faster than any one user can actually type, so that's fine. And then the other metrics are all comparable. Use a few megabytes of memory, a little bit of messaging, and the file save size is only like 50% bigger than the actual plain text. It's pretty nice. I would argue that Collabs modularity actually made this easier. It's modularity meaning that like each CRDT is its own class that can do whatever it wants. That meant we could like write and rewrite the list class without tearing out the rest of the library. And also the library has sort of low overhead. When you send a message over the network with your own custom class, it'll add a little bit of metadata, but not too much. So that means that if you want to do better, like you want to make a more optimized thing, then go for it. The library is not going to slow you down too much. Maybe if you want to apply heat trees, gzip, etc. So we're not stuck with this performance if you decide it. Okay, so in conclusion, Collabs is a TypeScript library for collaborative data structures. We've built in basic CRDTs, paratext, fugue, list with moves, and cool stuff like that. But you can also add your own collaborative data structures either from scratch or via object-oriented composition. If this sounds interesting to you, I encourage you to try it out. We've got a docs website. You can find more information about this stuff at my personal website. Thank you.
awesome presentation, Matt. You never disappoint. And I just mentioned that you break down conflicts and CRDTs in English for most people, and you didn't disappoint on that front as well. I would love to see the presentation in the show Lo-Fi channel so that others can look back and take a look at it. There's a lot of great content there, and I'm sure other people will have some questions. So this is the end of the meetup. I'm gonna stop the broadcast and the recording.